Today, we will learn about VSEPR theory. VSEPR is the abbreviation for valence shell electron pair repulsion. This theory provides a simple procedure to predict the shapes of covalent molecules. We are already aware that Lewis structures do not explain the shapes of molecules. They just tell us about the bonding in a molecule. So VSEPR theory helps us to predict the shapes. Following are a few points of this theory which we need to learn before we start predicting the shapes of molecules. In a molecule, you have the central atom which is surrounded by other atoms. So the shape of the molecule depends on number of valence electrons. It may be bonded or non-bonded. So the shape entirely depends on the valence electrons around the central atom. Now, these bonded and non-bonded electron pairs which are present around the central atom, they are negatively charged, which causes repulsion. In order to avoid or minimize the repulsion, these electron pairs, they tend to take positions as away from each other as possible. Electron pairs are trying to stay away from each other in order to avoid or minimize the repulsion. So they move to maximum distance. They move away from each other to the max. In the next point, we learn that according to VSEPR theory, the valence shell is a sphere and electron pairs are present at maximum distance from each other. So they are placed as away as possible from each other. For simplicity's sake, we consider multiple bonds as single bonds. So all the double and triple bonds are considered as single bonds when we are finding out the structure or geometry of the molecule. And the electron pairs they have, double bond has 2 electron pairs, triple bond has 3 electron pairs. These electron pairs are treated as a single super pair. They are treated as a single super pair. If you have more than 2 resonance structures, or if a molecule can be represented in different canonical structures, VSEPR theory can be applied to any of the canonical structure. The repulsion between electron pairs, whether bonded or non-bonded, is decreasing in this order. So lone pair lone pair repulsion is maximum. Then comes lone pair bond pair repulsion, and the least repulsion we see is between bond pair and bond pair. That is because lone pairs are localized only on the central atom. Lone pairs are localized only on central atom, whereas bonded pairs are shared between 2 atoms. Bonded pairs are shared between 2 atoms. So the lone pairs which are localized only on the central atom, they occupy more space as compared to the bonded pairs of electrons. So since they are occupying more space, hence they cause more repulsion. In order to predict the geometry of the molecules, it becomes much easier if we divide the molecules into 2 categories. First one, molecules in which the central atom has no lone pair, and the second one is molecules in which central atom has one or more lone pairs. Please note that we are talking about central atom only. We are The other atoms which are attached to the central atom may or may not have lone pairs. It does not matter. So the geometry entirely depends on the lone pairs, presence and absence of lone pairs on the central atom. So we will study about these two different categories in our next video. Thank you.